Welcome, field professionals and contractors, to today's Explainer. I'll be your senior concrete technologist today, and we are diving into a masterclass on a critical piece of concrete technology: construction joints. Look, in massive concrete pours, structural integrity absolutely has to dictate your field execution. Today, we're going to break down the hard science and the strict standards that separate a structure designed to last a century from one that literally starts failing the second you strip the formwork.
All right, let's just jump right into the explainer. Here is the agenda we'll be mastering today. Number 1, planned versus cold joints. Number 2, the shear zone rule. Number 3, step-by-step surface prep. And number 4, a pro tip on watertight joints.
Section 1, planned versus cold joints, establishing the baseline. Let's get into it.
Listen, out in the field, a joint is either an engineered feature meant to relieve stress, or it's a massive defect caused by poor site management. We all know placing concrete in one giant continuous pour is usually impossible. Our batching capacity, our crew sizes, the clock, they all demand that we break the pour up. When we do this intentionally, we get a planned construction joint. It's a smooth transition that maintains structural continuity. But when our logistics fail us, well, we end up with something completely different: a cold joint. The American Concrete Institute actually spells this out very clearly. They define a cold joint as a failure of intermingling and timing. If your concrete placement is delayed for too long, usually just past that initial setting time, the fresh concrete just can't blend with what's already there. You haven't just paused construction. You've actually inadvertently sliced your structural element right in half. You are leaving a weakened plane that the structural engineer absolutely did not account for in their original design. Moving right along to Section 2, the shear zone rule, rules of engagement. Now, this is crucial. As engineers, our primary concern is load transfer. So listen up, because this next question highlights exactly where and why massive concrete structures fail. Why is a high shear zone literally the absolute worst place to stop your daily pour? Well, the engineering rationale is pretty straightforward. Any construction joint, no matter how perfectly you prep it, naturally introduces a slip plane into your concrete. Because of this, it is mandatory that you locate joints at points of minimum shear or points of contraflexure. So usually right in the middle third of a span. Putting it mid-span protects that weakened plane from critical shear stress. Messing this up drastically compromises your load capacity. In fact, data from the International Research Journal of Engineering and Technology shows that even a properly placed mid-span vertical joint can slash overall flexural strength by up to 55% compared to a monolithic pour. Imagine if you incorrectly place that joint near a support where shear forces are highest. That structure is basically doomed to a shear failure under maximum load. All right, Section 3, surface prep, step-by-step, tactical execution. So how do we actually handle the physical prep of the substrate on site? You've got to rigorously execute these 3 steps to guarantee shear friction and bond strength. First up, you absolutely must remove the latents, that weak, powdery layer of cement and fines on the surface. You've got to roughen the concrete to a proper International Concrete Repair Institute, or ICRI, concrete surface profile. Hit it with a high-pressure water jet or mechanical sandblasting to get that aggressive texture. Step 2 is paramount. You need a saturated surface dry, or SSD, condition. If your existing substrate is bone dry, it acts just like a sponge, literally robbing your fresh mix of the vital water it needs for cement hydration right at the interface. You have to soak the concrete, then remove all the standing surface water. Make it internally saturated but superficially dry. Finally, during the new pour, vibrate that fresh concrete thoroughly against the old surface to force the paste deep into those roughened grooves. And that brings us to Section 4. Pro tip: watertight joints, advanced deployment. If you are working on liquid-retaining structures, subterranean networks, or any heavy civil projects, managing water ingress is your #1 priority. Longitudinal joints in heavy underground structures, like a massive circular tunnel, have to be meticulously, systematically planned at the invert and the arch. Because the structure faces extreme hydrostatic pressures from the surrounding soil, the joints cannot just be concrete resting against concrete. We need specialized intervention to prevent devastating leaks. To get a genuinely watertight structure, you have to embed flexible water stops. We're talking PVC, neoprene, or natural rubbers directly into these engineered gaps. Now, these water stops should be a minimum of 9 inches wide to make sure you get adequate concrete embedment on both sides of the joint, and generally about 3/8 to 1/2 inch thick. For the ultimate protection, especially if you're expecting some movement, you'll want to pair that water stop with an elastomeric sealant applied to the liquid face of the joint. That ensures high hydrostatic pressure cannot breach your structural envelope.
I want to hammer this next point home because I know scheduling pressures are real, but they can never trump our engineering standards. Here is your undeniable golden rule. Speed of pour is always secondary to joint quality. Pushing your crew to finish a placement without properly preparing the surface or pouring right up to a high shear zone just because you've got a line of concrete trucks waiting, that is professional negligence, pure and simple. So I'm going to leave you with this final critical question to chew on. Are your daily volume quotas compromising the structural lifespan of your concrete? Seriously, take a hard look at your site practices. Ask yourself if saving 30 minutes today by skipping a proper saturated surface dry preparation or ignoring a minimum shear location is really worth a catastrophic structural failure tomorrow. Master your joints, control your quality, and your structures are going to stand the test of time. Thanks so much for joining me for this explainer.